Welcome to the last video on confidence intervals, and this time we're going to be dealing with population proportions or confidence intervals for population proportions. All right, so for a proportion, we're going to jump right into we don't know the population, and we're just trying to estimate the population given our sample. So we are going to be using p hat now instead of x bar, since x bar was for means, and our standard error, because we're using our sample to do standard deviation, so it becomes standard error, is just like with the central limit theorem, except the p's become p hats. So it's a very similar formula. And in order for us to use this, we are going to have to, this will come up multiple times, use the np and n times 1 minus p hat have to be greater than or equal to 10. So graphically, what does this mean? This means now our center, instead of being p, is p hat, and our standard deviation becomes standard error, and our p's become p hats. All right, so the checks, the conditions for us to be able to do confidence intervals is, I don't like that it's listed SRS. It's really randomization is what we're checking, so that we know we have proper randomization so the statistics will come out correctly. So if you're doing an observational study, you could have a simple random sample. You could have a stratified random sample, as long as for your situation it's an appropriate random sample. Now, if you're doing an experiment, you just need to know that the randomization for treatments was done correctly. And then our book used to call it normality. I believe the current versions now call it large count, so that we can use, our count is big enough compared to our proportions that we can use the central limit theorem, and that's the np hat and n times 1 minus p hat being greater than or equal to 10. And then if we're sampling, then we need to check that our sample size isn't too big. So we have to check the 10n is less than n condition. So 10 times sample size is less than the population size. All right, now for the confidence interval. So the confidence interval should look very similar. Instead of x bar, we have p hat as our center, plus or minus our margin of error, where we have z critical. Now notice we don't know the population, but we're still using z. Unlike means, there's no t distribution for proportions. The t distribution is only for means. All right, and then our standard error is the p hat times 1 minus p hat over n and the square root. All right, so let's do an example. We have a social scientist is looking to see how often undergrads in psychology and communication pray. They asked 215 undergrads in those majors, found 107 of them prayed at least a few times a year, and we want to create a 95% confidence interval. So I'm going to talk you through this, and then we'll do a bunch of examples in class. The parameter, the P we're interested, the population, is the proportion of undergrad students in psychology and communications who pray a few times a year. So we're interested in all the undergrad students at this college, because remember, your sample has to be representative of your population. Then the conditions, says in the question, simple random sample. Then np hat has to be greater than or equal to 10, and n times 1 minus p hat has to be greater than or equal to 10. So I'll just do the n times p hat, and then I'll leave it to you to check the other one. So if I do n, we got 215. That's a 15. And our p hat is 107 over 215, so this makes the math really easy. 215. 107 is greater than 10. And actually, if we can just do the other one, 1 minus p hat. So 1 minus 107, let's see, that'd be 108. So 108 is greater than or equal to 10. Independence, we would have to say we assume there's more than 2,150 undergrad students in psychology and communications. All right, then with those checks, we can go to the calculator. All right, so in the calculator, we have, go to the same place, stat, over to tests. Now, don't go to z interval, because if you go to z interval, it's going to ask you some questions that you can't answer. So it's going to ask you, if you go to stats, it's going to ask you the standard deviation, your mean. We don't have that information. What we do want to do, and with proportions, this is true for everything in this calculator, it needs to have the words prop, P-R-O-P, for proportions. And again, we're not in tests yet, so you got to keep scrolling down. Keep scrolling. There we go. Now at A, we have one proportion z interval. That's what we got. We got one proportion we know about, and we're looking to make a z interval. So you press enter. The x value is the numerator of your proportion, the number of successes. So we have 107. And then the n value is our 215. We're doing 95% confidence. And there we go, we got our confidence interval. Now, if you need to show work for this, notice it gives you your p hat, and then the z critical for 95% is 1.96. So hopefully you'll get used to the 1.96 for 95%. And you can just then fill in the formula with these values and you know what it should equal. So this interval goes from about 43% to 56% of the undergrads. So we would say we are 95% confident that the true population proportion of undergraduates in psychology and communications who pray a few times a year is between 0.43 and 0.56. All right. Then we have some things that come up with proportions that aren't true for the means. All right. So if we're trying to calculate a specific sample size to get a certain margin of error, often we don't know what our proportion is because we haven't done the experiment yet. So what we want to do is the worst case scenario. And the worst case scenario in terms of statistics is 50-50 because neither side has more of a chance of succeeding. So we're going to do a margin of error example, and the p star is just when you don't know the p hat value, you use p star as 50-50 for worst case scenario. All right, so that's where this formula is saying. So it's taking your z critical and then your 50-50 here and whatever your margin of error you want, and then solving for your sample size. All right, so our last slide, we'll do one of these. We got a company wants to do a customer service survey where they rate on a scale of 1 to 5, with 4 being satisfied and 5 very satisfied. The president is interested in the percent of customers who rate them a 4 or 5. She wants the estimate to be within 3 percentage points at a 95% confidence level, so plus or minus 3%. It's too unreliable to ask everybody, so how many people should they survey? So we are doing 95%. Our z star is 1.96. Then we do a square root of 0.5 times 0.5 over n is what we're solving for, and we want this to be less than or equal to 0.03. All right, and then we go to our calculator. right, so we're going to do, okay, so we have to do 0.03 divided by 1.96. I'm going to have to square that. All right, so then I have the square, so now I have 0.5 squared over n on this side. And okay, so I'm going to take the reciprocal. All right, and times by 0.5 squared. All right, so my sample size, you can do the math out yourself and see that I did it correctly. So the sample size has to be at about 1,068. We want 1,068 people to be with it so that we would be within 3 percentage points in the confidence interval. All right. So big takeaways here are that we do P confidence intervals with our sample proportion, and they're always Z means. If we know sigma, it's a Z interval, but if we don't know sigma, it's a T interval. All right, so that's it on confidence intervals.